We're in TechMath 2, and we're in section 3-2, which has to do with making your calculator do something. So before we do that, we will come up with something that we should have memorized. So we're going to go 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees. And then we're going to say, well, what is the sine of that angle? And we're going to put a 0, 1, 2, 3, 4. And then we're going to go square root, square root, square root, square root, square root. And then we're going to divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. And then we're going to say, well, the sine of 0 is 0. The sine of 30 degrees is a half. The sine of 45 degrees is the square root of 2 over 2. And 60 degrees is square root of 3 over 2. And 90 degrees is 1. And that's how you remember what your sines are. And then you say, well, what are the cosines? Well, the cosines are the same in the opposite order. So 1, the square root of 3 over 2, the square root of 2 over 2, 1/2, and 0. And then you ask yourself, well, what is tangent? And tangent is going to be a sine divided by cosine. So sine divided by cosine is 0. Sine divided by cosine is square root of 3 over 3. When I rationalize the denominator, that's going to be 1. And this is going to be the square root of 3. And that's going to be infinity because I'm dividing by 0. And that's the memory device that I use. If I'm going to make it, if I don't remember those things, that's how I'm going to get them. Okay, so prior to taking the SAT exam, on my scratch piece of paper, as soon as they say go, I put that down so that I know what the sines and cosines and tangents are in case I'm asked. Okay, no one asked. Okay, well, that's fine. So now the issue is, if I have 37 degrees and I want to find the cosine or the sine or the tangent, what am I going to do? I'm going to, back in my lifetime, before we had these cool calculators, we would have a sine table, and we would look it up, and we would interpolate, because we'd have the sine of every fifth degree or so, and then we'd do an interpolation. If we wanted 37, we'd interpolate between 35 and 40. We'd find the average, basically, is what we would do. But today we don't do that anymore. We don't even teach you how to read a sine table anymore. So, you know, that's pretty disgusting, right? If there were papers in the room that had sine tables on it, you wouldn't even know what they were. So anyway, on my calculator, I'm going to hit sine 37, enter, and it's going to tell me 0.6018. And any more than 4 significant digits is way too many. And of course, that's the sine guy because I hit the wrong button. I put them in the wrong order. I put them in alphabetical order. I don't believe it. How did I go cosine, sine, cosine, tangent? We normally go sine, cosine, tangent, right? So I put them in the right order, and 37. 0.7986, and the tangent of 37, I get 0.7536 if I round up. And then I say, well, I know that the cosine of theta, well, that's not a theta, that's a phi. Cosine of theta is 0.7986. I want to know what theta is. So what am I going to do? Well, on our TI-86 Pros, we're going to hit the cosine button twice, and it'll come up with the arc cosine. So this doesn't mean 1 over cosine, which is secant. That's not what that means. This means arc cosine, which means the inverse of the cosine function, which is slightly confusing, but what we have to put up with. So then I'd put in 0.7986, and I'd come up with 37.00338 degrees. And then would say, well, we call it 37 degrees. I do the same thing. I look at the arc sine of 0.6018. 0.6018. Hit the sine button twice to get arc sine, 0.6018. And I get 36.99892. And I say, well, that's 30. Well, I'm going to round that off to 37. And I can get the arctangent. I want the arctangent of 0.756, 0.7536. So I hit the tangent button twice, get the arctangent, 0.7536, enter. And I get 37.001679, and I'd round that off to 37 degrees, and everybody would be happy. So that's how I'm going to go from the sign of something to some number back again. Now, my sine function, if I look at my sine function as it's plotted, it's going to do something like that. It's going to go all the way up to 1, all the way down to -1, and it's going to repeat itself every 360 degrees. And 60 degrees. So if I say, well, sine, the arc sine of 1/2 is equal to what? Well, I look at that guy, and this guy goes the other way too. It goes up and down this way as well, repeating itself every 360 degrees. If I do that, and I draw a line at where the 1/2 is, well, that was really good, wasn't it? 1/2. I say I have multiple answers. In fact, I have an infinite number of answers for that. Now, what is true of a function? Well, the truth about a function is if I have a function, then for any particular argument, I only have one answer. So in order for something to be a function, I look at this graph here and I say, well, that's a function. For every point, for every x I have, I only have one y. But if I had a graph that looked like that, a circle, and I say, for that x I have two y's, this is not a function, because I can't have two answers for a thing. That's not allowed. All right, well, that being the case, how can my calculator know which one of these guys to pick, whether they pick that one or this one or that one or this one or this one or that one? The answer is your calculator is only going to give you an answer between minus 90 degrees and 90 degrees. So the sine function is only going to give you an answer in that range. So if your answer is really someplace else, you're going to have to figure it out. Okay, and we'll end up doing that later. When we look at the cosine guy, he's going to do a similar thing. So the cosine function starts at 1, goes down, goes up, goes down, goes up, and goes in the negative direction too. Starts at +1, goes as low as -1, and repeats itself every 360 degrees. And if I draw a line in there at 1/2, I get multiple answers. So your calculator is not going to be able to handle that, but it will give you an answer between 0 and 180. Okay, so it will give you an answer between 0 and 180, and those are the only answers your calculator can give you. I look at the tangent function, and the tangent function does something like this. Oh, I'm just so wonderful at my drawing. Isn't that great? When it passes through 90 degrees, it goes to infinity. And when it passes through 180, I'm at 0. When it passes through 270, I'm now asymptotic, and I'm going to infinity again. And at minus 90, I'm doing the same thing. So now I have the same problem. If I say I want the arctangent of 1, and I expect to get 45 degrees. Well, which 45 do I get? Do I get that one, or this one, or that one, or this one? Which one? So my calculator is only going to give me an answer for the arctangent between 90 and minus 90. So when I do this arctangent thing, I get an answer between 90 and plus and minus 90. But I wouldn't get an answer of 120 if 120 was the right answer. And the calculator wouldn't know that 120 is the right answer. You have to go in and do that yourself. Okay, enough of that. But it's a calculator thing. Can I make my calculator do what I want it to? All right, we'll start on working problems. Before Nate walked in, I think we did this. This is a memory aid to come up with sines and cosines. So because it's such a wonderful thing, we'll do it again. So I've got 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. And I'm looking at the sine of something. I go 0, 1, 2, 3, 4, square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, divided by 2, divided by 2, divided by 2, divided by 2. And I remember to do that, and then once I've done that, I find that the sine of 0 is 0, the sine of 30 is a half, square root of 2 over 2 for 45, square root of 3 over 2 for 60, and 1 for 90 degrees. And the cosine is going to go the opposite way, so I go 1, the square root of 3 over 2, the square root of 2 over 2. Notice that 45 degrees of sine and cosine are exactly the same, 1/2, 0. And then I say, well, tangent is going to be sine over cosine, so that's going to be 0. This is going to be square root of 3 over 3, 1, square root of 3, undefined, infinite, because I'm dividing by 0. Okay. And we will do that often, but that's how I remember those numbers. If I don't remember those, I'll remember those numbers, but if I don't remember those numbers, I can write down that memory aid and get there anyway. All right, so I'm looking at number 1, and I want the sine of 18.5 degrees, and I want it to 4 significant digits. Okay, so we're going to look in the back of the book and see if I have a sine table. And no sine table. Bummer. I'm going to have to use my calculator. Sine 18, oh, it's not on. Sine 18.5. 0.3173. Number 1. All right, we'll do number 2. We want the cosine to 7.6 degrees. Cosine to 7.6, enter, 0.8862. Well, we'll do tangent next. Number 3, tangent. For 1.4. 41.4. Tangent, 41.4. What? 0.8861. 16. I thought it was the same as the other guy, but it's not. Okay, well that seems all right. Why don't we move down to the secant, number 7. So number 7, secant of 34.7 degrees. All right, so what we're going to do is going to say that's the same as 1 over the cosine of 34.7 degrees. And now we're going to put that in our calculator. 1 divided by the cosine of 34.7 close parentheses, and I end up with 1.216. So I remember that I don't have a well, if I have a TI 85, 86, 89, 92 calculator, I do have secant buttons and cosecant buttons and cotangent buttons. But I may not be able to find them because I didn't bring my 500-page manual with me. Okay, so that's the other issue. So on the TI 36, well, that's the way we would do it. We would do it that way. Cosecant, number 8. We want the cosecant of 80.5 degrees, and we remember that that's 1 over the sine of 80.5. So we put in our calculator 1 divided by the sine of 80.5, and I get 1.0139, and 1, 2, 3, 4, 5. That's 5 significant digits. I'm only supposed to have 4. 1.014 due to significant digits.
You give me a negative number, right?
No, it's not giving me a negative number. Why would you want it to give you a negative number? I mean, you have the same calculator I do. 1 divided by the sine. How did you do? Oh, see right there? What did that say? Okay, that says radians. So the calculator is in radians. It needs to be in degrees. Now it's in degrees. And now 1 divided by the sine of 85. So your calculator could be in radians, in which case you'd get a different answer. So 80 radians is some huge amount of degrees, right? Yeah. All right, so where were we? Should we, no, I don't think so. I think we should do 20. We'll do 19 next. I've got the sine of theta is 0.4305. What I'm going to do is I'm going to take the inverse sine of the sine, so I'm taking the inverse side of both sides of the equations. Now, I'm doing this in my head. I'm writing this down just to show you the math of the situation. So if I take the inverse function of the function, I get the argument. So I end up with theta on that side, and then I put in my calculator arc sine 0.4305, and I end up with 25 point, and I'm supposed to get to the nearest tenth of a degree, 5 degrees. Okay, that was 19. Okay, I'm not going to do that again, but that's what I'm doing. I'm taking the arc sine of both sides of the equation to getting that theta is equal to something. Okay, number 20. I have the cosine of theta 0.777371. So theta is going to be the arc cosine 0.7771. Arc cosine 0.7771, and I have 39.0 degrees. Number 21, got the tangent of theta 0.4684. Theta is the arc tangent 0.4684. 0.4684, 25.1 degrees. And then we'll go for a secant guy. All right, so we'll go 28 first. Number 28, looking for the cotangent of theta is 3.270. Well, that doesn't do much for me, right? But if I go 1 divided by the cotangent of theta is 1 over 3.270, then I get the tangent of theta is equal to something. 1 divided by 3.270, 0.30581. And then I can come up and say theta is the arc tangent of 0.30581. Arc tangent, second function answer, and I get 17.0 degrees. So that's how I would do it. If I have the cotangent or the secant or the cosecant, that's what I would do. We'll do the secant guy next, number 29. So I got secant theta 2.363. I'm going to divide them by 1, and I'm going to get that the cosine of theta is 1 divided by 2.363, 0.42319, and theta is the arc cosine 0.42319. Arc cosine, second function answer, 65.0 degrees. Okay, did we do a cosecant one yet? No, we didn't. So we'll do number 30, the cosecant one. Cosecant theta 5.662. Divide by 1, we have sine theta is equal to 1 divided by 5.662, 0.17662, and then theta is equal to the arc sine of the guy up there. Arc sine, second function answer, so I don't have to rewrite it. 10.2 degrees. Okay, turning the page, looking at number 42. Use a calculator to find each angle rounded to the nearest hundredth of a degree. All right, no problem. I mean, it wouldn't matter. We could have put that down for the other ones too, right? So we have a secant theta 1.2566, make them 1 over, and we have cosine theta equals. Well, we won't even do that. We'll just put down the answer directly, right? So we're going to go arc cosine of 1 divided by 1.2566. And we're going to come up with 37.2 0.27 degrees. Okay, so I skipped the intermediate step. I just did it in my calculator. I was doing it in my calculator before when I was doing the second function answer. So I was bringing this answer into the arc cosine guy, but there's no reason I have to do that. I could just put it there to begin with. All right. Now we get to do the same thing over again. Round your calculation to 4 significant digits. Okay. So I'm looking at 43, and I need the sine of 36 degrees, 24 minutes, and my calculator, does it do that? It might do that. Let's see if I can make it do that. Sine 36, second function, I'm looking at vectors, math, edit, no, it's not second function vector. Second function complex, polar magnitude, conjugate, no, it's not there. Is there a math button? Random, matrix, quit, recall, base, convert, constants, operation. There's a math button. We'll try that. Math. Oh, there it is. Math, degree, minutes, seconds. Okay, so I'm going to put in, I put in 36, I went to math, I went to degree, minutes, seconds on math, and I'm putting in degrees, and then I'm going to put 24, I'm going to go to math, and I'm going to go to degrees, minutes, seconds, and I'm going to put in minutes, and then I'm going to hit the enter button, and I'm going to have 0.5934, and I'm supposed to do this to 4 significant digits, so I did. Okay, so what did I do? I wanted sine 36 degrees, 24 minutes. When I hit the sine button, 36, I hit the math button, I moved over to degrees, minutes, seconds. I came down to the degree guy, I hit enter, and then I put a 24, I hit math, degrees, minutes, seconds, down to the minute guy, put in 24, and hit, put a close parentheses on it, and then hit enter. And then that gave me my answer directly. Now, if I didn't remember that I had that on my calculator, then what would I do? Well, I'd say, well, this is 36 plus 24 over 60. 36 plus 24 divided by 60 is 36.4 degrees. And then I'd enter the sine of 36.4 degrees. Sine 36.4, and I get 0.5934, the same answer. Okay, but my calculator will handle degree, minutes, and seconds for me, so why not let it do it? You know, that would be my position on the situation. All right, so we're going to look at, we'll look at 45. So we want the tangent of 52 degrees, 43 minutes, 38 seconds. So I'm going to hit tangent, 52, math, over to degrees, minutes, seconds. I got a degree. 43, math, over to degrees, minutes, seconds, come down to minutes. I have 43 minutes. 38, math, degrees, minutes, seconds, come down to minutes. I got that, close parentheses, hit the enter button, 1.314. If I didn't want to do that, I'll write 1.313982259 is what my calculator has, but I only want I only want 4 significant digits, so I'd only write down that as my final answer. Or I could go tangent 52 plus 43 over 60 plus 38 over 60 squared, close parentheses. So tangent 52 plus 43 divided by 60 plus 38 divided by 60 squared, and I would get 1.313982259, same answer that I had before. So I could go either way. Okay, dropping down to number 54. We want the cosecant of 7 degrees 52 seconds. Okay, so I want 1 divided by the sine of 7 degrees 52 seconds. All right. 1 divided by sine 7 math degrees minutes seconds degrees 52 math degrees minutes seconds seconds, close parentheses, enter. Syntax error.
Yeah, so I can get the same thing. So
Syntax error.
does it have to have a degree? It doesn't have to have a minutes there before you have a second, so you have 0 minutes now?
Wow. It must. Wow. Okay. Math. All right, back. Okay, we're going to put in 0 math degrees minutes seconds math degrees minutes seconds. Boom.
Yeah.
So I got 7 degrees 0 52 math degrees minutes seconds seconds. Okay, so now what I have in my calculator is 7 degrees 0 minutes 52 seconds, and now I get an answer. 8.18869.154. Okay, so yes, it appears that it's not, the calculator won't like it if you don't put in the minutes, even though it's 0. Stupid calculator. Let's see, 4 significant digits, so I really only want 8.189 would be my final answer. Alright, use a calculator to find these guys rounded to the nearest second. Okay, we're going to round it to the nearest second. Why not? 55. The sine of theta 0.8556. So theta arc sine of that guy. So arc sine 0.5088556. Okay, so we got 58.826, blah, blah, blah. But I want degrees, minutes, seconds. If I go back to math, degrees, minutes, seconds, and I come down, I want to do 6. 6 is change to degrees, minutes, seconds. Okay, so the answer, I'm going to change the degrees, minutes, seconds, and I end up with 58 degrees, 49 minutes, 34 seconds. All right, so I've got my answer in degrees. I go to math. I go to degrees, minutes, seconds. I come down to the 4th guy down. the fifth guy down, the sixth guy down, which is a change to degree minute seconds. Now it changes directly to degree minute seconds. Okay, so I can't do that on my calculator, so I write down 58 degrees. I truncate it off, and I have 0.82608354. I multiply that times 60. All right, so I've got 0.82608354 times 60. I have a 49.5650124. So I'm going to put 49 minutes. I'm going to get rid of the 49 and have 0.5650124 left over. I'm going to multiply that times 60. And I got 33.9, so I'll make that 34 minutes. So I can do it on my calculator with 8th grade math, or I can do it on my calculator using the degree minute second conversion key, which
How'd you do that again?
which part? The new one?
Convert it on the degrees, minutes, and seconds.
Not okay. So I went to my calculator, and I have a number, 54.27382 degrees, whatever it is. So I go to math. I go to degrees, minutes, seconds. I go down until I find number 6, which is a convert to degree, minute, second key. I either hit 6 or I hit enter, one or the other. And then my calculator has it has answer, and then convert to degrees, minutes, seconds. On my calculator, I hit the enter key, and it gives me degrees, minutes, seconds. Okay? Cool enough? I think so. Given all the other things we have to do in the world. Okay. We'll do 66, and then we'll take attendance and go home. Well, I don't know about going home. 66. What we should do is we should open up the blinds so we can see when it starts snowing. Why have a room with windows if we don't? Not yet. Totally disappointed. When I lived in Maine for 4 years, and in Maine in January it dropped below 0 and stayed there the whole month. None of this going up and down stuff. And we had 18 inches of snow in 6 hours one day, and nothing stopped. The schools didn't close. Everything was still open. Everything went as normal. The snowplows kept up with it. It was fine. 6 hours after that snowfall stopped, another 18 inches fell in 6 hours, at which time everything stopped. Nothing could keep up with it now. All right, well, we want the cosecant of 8.1407. And we know the cosecant is 1 over the sine. 1 over the sine of theta. Okay, so what we're going to do is we're going to go 1 divided by the arc sine. No, we aren't. We go the arc sine of 1 divided by 8.1407. Then we're going to go, so arc sine 1 divided by 8.1407, close parentheses, hit the enter key. Okay. And then we're going to go math to degrees, minutes, seconds. 6. Okay, math. Degree, minute, second, enter. Something went wrong. Math. Degrees, minutes, seconds. Okay, math. Degrees, minutes, seconds. Oh, I got to come down to 6. That's all right. Boom. Oh, now I'm okay. Degrees, minutes, seconds. I don't hit an enter. Degrees, minutes, seconds. Come down to 6. Hit enter. Hit enter again. And I have, what I got? 7 degrees, 3 minutes, 22 seconds. Okay, good enough. Now, can I go from degrees, minutes, seconds to the decimal degree? That would be the next question on our mind. And the answer appears to be no. So if I have something, I'm going to try 10 degrees, 10 minutes, 10 seconds. And see if I can change that. Okay, so I have a 10 math degrees, 10 math seconds, minutes, 10 math shit, did it wrong again, math. Okay, so I got that, and then I'm going to go math. I'm just so closed. Math. I'm going to use the degree, minute, second guy to see if I have it in degree, minute, seconds, and I use the degree, minute, second guy if I get decimal degrees, and I don't. So the calculator it won't allow me to take this and send it directly into decimal degrees. At least I don't see how it does.
You type it in just like that, and then hit the
Oh.
enter button.
Oh, you think that might work?
Yeah.
All right, so I'm going to go and clear this out. 10 degrees, 10 minutes, 10 seconds, enter. Oh, yes, it does. Oh, yeah. So you do get decimal degrees. All you got to do is hit return. So once you've entered it, 10.1649, 9444444. Does that mean the 4 goes on forever? No, I can't really tell. All I can really tell is I got 1, 2, 3, 4, 5 4s in a row. So my calculator will do both. Will go both ways for me. Isn't that disgusting? All right, so the next thing we'll go do before we leave is take attendance, and before we do that, we'll